Hello, all. Welcome to another session from We Are Learning. Today, we have taken another interesting topic, uh, a statistical methodology called Monte Carlo Simulation. Just to give a brief background about Monte Carlo Simulation, I picked up a couple of lines from Wikipedia and data science um, web portals. Monte Carlo is a methodology. It uses randomness to solve any problems. This is widely used in many industries to understand the impact of risk and uncertainty. Widely used industries are financials. You can use it in your project management. You can use it in any other cost or forecasting models, which will try to give a better idea to see what could be a potential outcome by considering the factors which can change your plan and then take a decision accordingly. So this is just to see what could be the most risk free decision that you can do. Again, this is done on a study purpose. Please do not use it in your real-time situation. We are trying to build a models and try to learn and explore many other areas using Python. So we will now get into today's tutorial. Today we have picked up Bank of Baroda as the stock, and we will try to apply the Monte Carlo simulation and see what could be the stock price from here to 1000 days. We have taken a record from 2017 onwards to try to understand what are the ups and dips of the stock and predict it how this would be going forward. So we have imported essential libraries, NumPy, Pandas, and one interesting library that we have brought in today is Data Reader, which can directly read from web. So you no need to download the data every now and then for industry where the data moves almost every minute. This would be a very good library to use. And then we have used matplots and then scipy stats to use these stat formulas. So let's try to import these libraries as the first step. Once these libraries are imported, we will pick Bank of Baroda stock from Yahoo Finance. The start date is from 1/1/2017 and the column that we are trying to bring is adjusted close because that is most relevant for us to go and predict what could be the upcoming day's stocks price. So the libraries are downloaded. Now I'm picking Bank of Baroda. You can see I'm picking it from Yahoo Finance. That's the source and it's from 1/1/2017 and I'm picking adjusted close as the column from Yahoo Finance. And then I'm trying to understand the log price first of all. So NP is from your NumPy and PCT change is the uh, usage of understanding the log price. And now let's try to see from the tail the latest value. You could see the last 5 values. It's on till 15th May that we have brought in. So this is Yahoo Finance, which is running on 15th May. So just to see it has been downloaded correctly or not. Yes, it is. We have found the log price. And now let's try to plot the log price. This is the stock price which we are seeing. Okay, so we can see from 2017 it was around 150 and now it has been crashed up to 42.43 on today's price. Now let's plot the log price and see how the movement is. It's quite variable. It is running. um, there is a formula to bring Monte Carlo simulation. So to get the formulas, you need to find the log means, the log variance, and from then you find the constant from the randomness, and from there you derive your daily price. From there we project what is the Monte Carlo simulation. So to get all those variables, I am trying to first pick the log mean that we got. which is around minus 0.001. And then also I'm trying to find what is the variance, that is 0.000813. And then I'm trying to take D, where is the log mean and half of the log variance that we take. And then I'm trying to get the standard deviation into S. Post that, now we are going to introduce the randomness, which is very important in the Monte Carlo simulation, because we want to find what is the maximum probabilities that we can see the stock price can fluctuate. So we have brought a constant x, finding the random on 10 by 2 one array, and then finding the ppf value of that and storing that back to the constant variable const. Once that is done, I'm trying to take an interval of 1000 days. The iterations is around 10. Um, so once we are able to declare these variables, I'm trying to put the formula over here. So I'm trying to understand the daily price, what it can do with this randomness involved. So I've brought this formula. So I brought this numpy on this exponential part to understand the drift value that I have, the standard deviation that I have, and then followed by the randomness with the intervals of 1000 days. Okay, with this I'm trying to understand and putting it in an array and find what is the daily price value that it goes. Please understand, we have used a log price, not the actual stock price. And now I'm trying to put the last value, the latest stock price value. That's why I use the -1, the last but one I pick up, and I'm trying to import those values instead of zeros in my numpy array, and we will see whether that has been taken up. Okay, so 42.799 is what currently running. You can see over here 42.80. So this is running with the latest price. I'm trying to replace that with the zeros in the numpy array, and then trying to bring a loop. So I'm trying to get the range for the t interval, which is 1000 days, and then trying to put my stock price into it, right? And trying to take my last value from there and trying to predict what could be the simulated values. So this loop runs for those 1000 days, right? And then we can bring that into our stock price. So this has filled up into all the numpy array. This is, I want to see in a graph. And now you can see we have derived a Monte Carlo simulation graph where we can see for the next 1000 days with the given factors we have as on today how this price can log. So this has 10 different simulations running into it for a 1000 days concept. So few are depicting that this will go on the lower side, few says it can go and hit till 60, and then it slowly drops, because you can take only the first 100 days or maybe 150 days, because the factors always changes, market changes, and that changes the value as well. So this is just an idea to use a Monte Carlo simulation. It is not to predict a stock price as such very really. It's just to give a broad idea with the given factor as on today. And if we simulate this for the next 1000 days, what could be the value that it can go? So you can randomly take the first 50, 100 days to understand what is the volatility which is happening inside the industry and how we can predict the stock. You can use this in various other industries. As I mentioned, you can use a project management and to see whether you will be able to achieve the results in the given time frame that you have promised to your customer. You may understand the costings that is happening in your businesses. You can use wherever you want to see a probability and try to reduce your risk factor when you're taking your decision. So this is another try from our side to explore a few other statistical methodologies that we have to predict some stock prices. I hope this will be of use for you, and please try to bring the data models like this and explore from your end as well. Post your comments if you have any, and try to learn as much as possible with the available resources, and try to build your own, so that we can learn together. I hope this tutorial would have been of a use for you. Happy learning. Take care.